Please feel free to raise your hand and I'll try to answer it. Yes, software. I think that is all software. Yeah, applications are in our lives every day, from the TV or mobile or computers. But also, some traditional business has been changed because of software. We have seen a lot of examples like Netflix, Airbnb, or Uber that they have changed something that was traditionally done in some way. But let me show you some examples. This is the cockpit of the A380, and notice that there is a lot of screens, or not touch screens probably, but screens. This is software. It even have a keyboard with a touch panel. So yeah, you can see there is a lot of software here. Also, this is really fun. This is a Tesla car. I mean, sometimes when you switch off on your car, it appears on a screen that says there is a new version of your Tesla Model S software. A scale installation is done now, or close the window to postpone. So this is something that probably most of us are not used to see this, but yeah, this is going to happen in the future. In fact, it happens in Tesla. Notice this. This is from 2015. It's only less than 1 year, and says Windows 3.1 is still alive and just killed a French airport. It was new that a French airport decided to migrate its software but containing the operating system. It was Windows 3.1, and everything crashed. And during one day, all the air traffic was ruled by hand, with manual, without using any computer. And the last one example is this. It's like 37 million slot machine being blamed on software error, casino won't pay. So yeah, you go to a casino, you put your money, you earn $57 million, and then they are not going to pay you because there is a software error. So software is everywhere. So we need to find a way to release the software faster, maybe because we have found a bug or the client found a bug and we need to fix it as soon as possible. Sooner, maybe because our competitors are going to release something and we want to take advantage of them. And of course, better to avoid this kind of problems with slot machines or cars or whatever. So, what is a continuous delivery? Well, maybe some people say, yeah, continuous delivery is a build tool, like Gradle or Maven or Rand. Or maybe it's a continuous iteration server. If I have a continuous iteration server, then I'm doing continuous delivery. Others think that having an automatic build, automatic quality, automatic deployment, this is that you are doing continuous delivery. And probably true, but I would say that it's only a part of it. The most important thing of continuous delivery is this: is deliver business value more frequently. You need to be able to deliver your application frequently, so you can get feedback from your users. Probably when you see here value, the first thing that you think is in money, but it's not only money. Maybe you try to one thing, you expect some feedback from users, see if they like the idea or not. And this is not directly on money, but it's quite interesting to know the opinion of your clients. And this is probably something that most of us have seen sometimes. This is the cloud continuous delivery pipeline, where you have someone who develops, it commits to somewhere, then it's built. This is the commit test, acceptance test, which here you can say acceptance test, a stress test, a grid test. One, do some kind of a static analysis. Then things are staged, and someone decides if this is deployed to production or not. And when it's released on production, then you have feedback loop from the users, but notice that you can even get feedback from all the stages to the development says, you upgrade something, or sorry. Oh, sorry. Listen everything, right? Okay, that's important. And yeah, you get the feedback, but also there is some business value on this, and your business earns more money, and everyone is happy.
But please, yeah, let's stop with a lot of theory and let's go into with some practice on code. Let's zoom in the continuous delivery pipeline, and this is the commit stage. This is the first part of your continuous delivery stage, which you have the source code, you compile it, you execute some commit tests, you do code analysis, you assemble everything, and finally, you release this to your artifact repository for reusing the same artifact in all your steps. So, how we compile with Gradle? Well, if you are using a war file, an application that is a war, you do apply plugin war. Then for all your projects that are, if you're using a multi-project project, you want to set that the Java version is the same for all the projects. You set the group ID, the version, and finally you set where you want to get the artifacts, which in this case is the Maven Central. Even you can define dependencies like this. Notice that I'm using provided compile, which is, I can use this. This is like the provided scope of Maven, and I can use it because it's of type var. And var also lets you define this scope. And then you can run Gradle, compile Java, and everything is compiled. But in Gradle 2.12, you can even use compile only a scope, which is more or less like the Maven provided scope. But yeah, it's more or less the same. But you can check the documentation, you'll see that there are small differences regarding the testing scope. Also, we need to run the commit test stage. And the commit test stage, well, you define your dependencies with JUnit, Hamcrest. You can even, probably if you are using JUnit, or you are writing unit test, you are going to use Mockito. And you need to exclude Hamcrest because if not, the class path is messed somehow, so you can exclude it in this way. And also, when you're using test, you can even use this thing. Well, in fact, this is a method which is called test, and then you can add some code. This is Groovy code before the tests are executed. So, for example, in this case, I'm getting all the system properties, and I am setting the URL where the test is going to be deployed. And this is, well, the property. So you use Gradle, and notice that I'm using here colon test, and this means that only the unit tests of the root project are going to be executed, because in the commit test phase, you only want to run the unit test of the root project. But unit test is not enough in the commit stage. You can run all your unit tests and still have maybe some failures. This is especially true when you are using features that are provided by the containers. For example, if you're using the REST annotations like JXRS or Spring MVVC, or if you're using JPA, all these classes that are annotated, it's the container who provides some meaning to that annotation. So with unit tests, it's not enough to be sure that you have not done anything wrong with your annotations. So you need to write integration tests. But not all integration tests should be run in this phase, because it could take a lot of time. So what you need to do is choose which tests are going to be executed. This is how I usually structure my projects, which I have in source. I have all the root of the project, and then I have one project for a stress test, another one for producer test, another one for integration test. So all integration test goes here. And to set this multiple project, or to register this multiple project is really easy. You only need to go to settings.gradle and do include and put the directory. That's all. With Maven, probably it's quite more difficult. You need to do the parent thing and so on. But here you only need to do the include of the directory, and Gradle will take care of everything else. And finally, since I've said that in the commit stage it should run pretty fast, you don't need to run all the integration tests because it's going to take a lot of time. But what you can do is choose some tests that are going to be executed, that are, the happy path or the some test that validates that at least the container can start up and parse all the notations, or that, the simple things works at least. So what you can do is, in test, I said, if the project has property happy path, we're going to see how to set this property, then filter all the tests and only execute this array of tests. So in this case, what I'm saying is that if I pass the happy path property, only the test should return the average will be executed. Of all the integration tests, only this one. So then I use Gradle, the name of the project, all the directory, test, because I only want to run the integration test, not all the tests of all the project, and -p to set this is happy property, and I pass here the property, which is called happy path. So when I execute this, only this test is going to be run. So our commit test phase runs pretty fast. Of course, we have the code analysis phase where you can use PMD, check style, find bugs, SonarQube. All these are provided by, are supported by Gradle. You can go to the documentation, you will find all the examples. There is not much secret here. And after this phase, you can let developers go. This means that this phase, until that point, it should take at least, or at most, 10 minutes. After these 10 minutes, it should be, or probably the application works. You have not break anything, probably. So you can say to the developer, wait this until this point before starting a new task. And if it arrives here, then you can move to the next task. And if then you run an acceptance test and then it doesn't work, yeah, we're going to fix it. But now, at least, wait until here. Because if not, if you start a new task before this phase, maybe you have break something, and then you have started another task, and then you have a new task in your workspace, then you have something that you need to be fixed, and you have two tasks at the same time. Yeah, the problem of multitasking and so on. So it's waiting until here, and if here arrives, okay, then start a new task. But of course, after that, the next thing that you need to do is running the integration tests. Because, of course, if in the previous test execution, you only run some specific tests. So here you start running a new container and run everything, the happy path, the path where you check that if there is an error, it works as expected, and so on. And this phase probably takes some more time. And in case you are using container, Java EE containers or Spring containers, one of the best tools, I would say, for this kind of test is Archillion. Also, you need to take care of the code coverage, and probably one of the best tools, or the de facto tool, is JCoco. Basically, because JCoco is on the fly bytecode instrumentation, so you don't, you are, since there is no modification of the source code, it's something done in execution, so your code is still the same that it's monitored. And remember that I've said that you're running your unit tests that are on the root of the project, and also we have the integration tests that are on another project. And probably what we want to have is a merge of this report. So you have only one report that merge the results of the both executions. So to use JCoco with Gradle, you do apply plugin JCoco. You set the version of JCoco you want to use. And finally, I created a task, which is of type JCoco report, because what I want to do is merge all the reports of JCoco. And then I said, okay, this is the main, this is the Java classes that I want to inspect. I add, by default, the test.exec file of the root project. Exec files are a binary file that is used by JCoco to store all his stuff about where you have, what methods has been called and what's not, and so on. And then, for all the sub-projects, I can use this variable. This is by default on Gradle. I said, for each one project, if this project in the build dir JCoco, there is a file test.exec, it means that JCoco has been run for that project, put it inside an array. Basically, if the file exists, I put in this array this file, this test.exec. Then I pass in the execution data, I pass this array in form of files, and I said that I don't want to report in XML and TSV, only as HTML. So when I run Gradle jcoco root test report, which is this task, all the jcoco reports is going to be merged into one simple report, and then I can see here that a typical jcoco report with integration tests and unit tests, all of them merge. One thing that is quite important in continuous delivery is versioning. Since in continuous delivery, every build is a potential release, it means that all the steps that should be done for each build should be as this artifact are going to be deployed on production. And this means that at the very early stages, you need to set a version, because if you don't set a version at that point, you're not going to be able to deploy it to the production, because you don't know exactly which, in this case, a WAR or jar file you need to use. And to do this, basically, there are a lot of approaches, but I think that the most common use is using the version. Probably your project is 1.0 snapshot. What you can do is do 1.0 dot and put the Jenkins build number. So since every Jenkins build number is unique, you can be really sure that this version is unique. And even it can help you to trace between Jenkins and your artifact. And how to do this with Gradle? Well, since Gradle is written in Ruby, I usually have a Gradle directory where I put all my Ruby Gradle scripts there. So I create here a versioning.gradle, which is a file which takes care of this stuff of creating and overwriting the version of the artifacts to the correct one. So basically, I put here a regular expression to say, okay, check 1.0 snapshot and get it in a form of matcher. Well, this is a regular expression. Notice here version. Version is a variable which is available in Gradle that sets you the version that you have specified in the file. In this case, it was 1.0 snapshot. Then if there is a matcher, I get the measure version, I get the minor version, and project.version, I say that, okay, the version of the project should be a new project version. This is a custom class with the measure, the minor, and system.m.source build number. This is the environment variable that contains the Jenkins build number. And the project version, it's 2 integers and 1 string. And Gradle, when they want to generate the version, it's going to call the toString method. So you override the toString and say the full version is the measure.minor. And if there is a build number, this is pretty good, because if you're using on your local machine, you don't have a Jenkins installed. So you need to take care of this case. Say full version, append build number as well, and return the full version. And that's all. Only doing this thing, the version of your application is going to be updated to this. After that, okay, we have our application. We have compiled it, running the test, and so on. It has a version that can be used in production. We need to package everything. And to package, first of all, you say, for all the projects, I want to apply the versioning.gradle script. So all the projects of my build will contain the same version and using the same approach. And then, if it's in a WAR file, you can use WAR to say, okay, I want to apply some steps when creating the WAR file. And I said, I want to put the manifest a new attribute called implementing version, and it's going to be the project.version.toString. And this is really useful because sometimes when you create a WAR, this WAR it's like Star Wars /1.0.3.war, but then this passed through some scripts, and then this WAR is Star Wars.war in production, and you really don't know exactly which war is. So it's interesting to have in the manifest which implementation version is having there. So you can call Gradle assemble, and then the war will be created with the correct version. We have the war. We have not done yet because we need to publish this artifact to a artifact repository to be reused in all the next steps that we're going to execute, because we don't want to compile every time. So how to publish? Well, probably most of you are publishing in Nexus or Artifactory, and this is a Maven repo, so you need to instruct Gradle to say, that Word file, I want that it's published as a Maven artifact. So what you're doing is, first of all, is say apply plugin Maven publish. This is the first thing that you need to do. If you know how these artifacts work, it says that you need to publish with your artifact and also your Java doc and also the sources. If you have, I mean that when you use any external API that you download from Maven, you see that you can even download the Java doc and the sources. To do this with Gradle, you need to create two tasks. One task that is called source jar, which is type jar, and when you say is make me a jar with all the Java classes from main, and then I do a Java doc jar, which is of type jar, because at the end this is a jar. That depends on Java doc. This means that when I want to execute this task, first of all, I'm going to generate the Java doc, and then what I say is that from javadoc.destinationDir makes the jar. So it means that all the HTML are put it inside this jar. Finally, to publish this, you're using publications. You said, okay, I want to use a Maven publication, which is a web application from this web. Notice here that I said, also I want that you publish two more artifacts, not only this one. And this artifact is the source jar, which is the name of this task, with classifier sources, which what it's going to do is do a star wars slash the version slash sources.jar, and the artifact the same for Javadoc. And then here you define where is the URL of the Maven repo. In this case, is the repo URL, which is get it from this variable. And then when you do Gradle publish, simply the Word file with all the sources and the Javadoc is going to be published on the Maven repo you have configured here. We have finished the commit stage. This is known as the first part of continuous delivery. The second part is the acceptance stage. This is where you run really, really long tests that basically checks the project from the business point of view. First of all, you're going to deploy this to an environment. I'm not going to show you how to deploy to environment because every environment is different. Probably someone uses Docker, others maybe deploys directly to bare metal, other ones uses Ansible. I mean that this depends on your environment. Then it comes the acceptance test, the stress test, the contract test, and test and test and test. It's really important to test your application. And finally, someone decides if you want to continue to the production or not. So this is an example of framework that really works pretty well for acceptance tests, which is Serenity BDD. Serenity BDD is an automatic acceptance testing with a style. It's quite funny because with Serenity BDD you can write JUnit tests or with acceptance test with JUnit or Cucumber or JBehave. Serenity BDD integrates with all of this. It creates a really interesting report. We're going to see now an example that you can see which feature has been covered, which not, which are implemented, which are not implemented. They organize it as well. And another thing that has Serenity BDD is that forces you to use the best practices on acceptance test, like, for example, using page objects, screenplay, pattern, steps pattern, and so on. And this is an example of the report that you can get. Notice that you have here 5 passes, 1 pending, You can see the pending is that it has not been executed. You even have pending in manual for exploratory testing. You have ignored failing tests, passing tests, or errors. You have here all the summary, and and here you can tag your tests, and then they group. And you can see here that the shopping cart feature, it has 2 tests, and one has passed and the other not. And in this case, the search API has 4 tests, which one has not implemented yet. This is the kind of report that generates Serenity BDD. Another kind of test is a stress test. You also need to be aware that your application is responding. And you can use JMeter, of course, but one approach that I really prefer is Gatling. Gatling is in a Scala DSL that basically allows you to program stress tests. Instead of relying on XMLs, which you have to write a lot of XML files or auto-generate it, but then you are forced to use what XML offers you. In this case, Gatling is it's a Scala, so it means that you can use a Scala language for writing your stress test. And it generates some kind of report like this, that the number of requests, here some statistics, more graphs, and means and average, and so on. It's a really good tool for writing a stress test. Another example of test is contract test. If you're moving, I don't like to say microservices work because it's like, oh, it's super trendy. But I will say services. Nowadays, probably you're using services, and you have one service that consumes something from another service, and that one service produces some output, and the other service consumes this output. And probably both services are done by different teams and evolve in a different pace. And this means that maybe you are developing pretty fast your producer, and you need to be sure that your producer is not breaking the consumer's part. So when you put your producer in production, your consumers will still be able to talk with this producer. And the same happens with if you are evolving a consumer pretty fast. And basically, one of the tools for doing this is Pact. And what Pact does is, first you have the consumer, and you do here a step with all the expected responses. For example, if you have a book service that talks to image service to get the cover of the book, here you're going to record statically, or you stop the response you expect from a producer. But you are not calling the producer. You are using this step. There are some projects in Java like WireMock or mock server for doing this kind of things. And then everything is recorded in a special file. Then this file is sent to the producer part, and what does Pact is execute all what you have, all the executions you have done here against the provider. If provider responds correctly with what you expect here, then it means that your consumer can still talk with your producer, so everything will still work. If not, it means that something has been screwed in somewhere, maybe the consumer or maybe the producer, but you have a way to detect it. And that's all from the perspective of Gradle. We have seen all the pipeline that you can run tests, execute static code analysis, package, publishing, and so on. So we need a way to orchestrate all these steps. Here we have seen that I've been executing all the Gradle steps manually, and we need to orchestrate in which order and how they can be executed. And obviously, I would say that the de facto tool is Jenkins. Jenkins is a tool, it's a continuous integration server that integrates in all the stages with a lot of technologies. In fact, it has over 1,000 plugins. And well, in the commit page, it can be, it integrates with this, and for deploying with Pivotal, Docker, AWS. I may say that this is the de facto and more versatile tool that there is currently for continuous integration. I suppose that everyone has seen this screen. Well, not this exactly because this is from Jenkins 2, but something similar, that you create a build, you put here execute a shell, you will execute here Gradle compile Java, and then as a past build actions, you put here that you want to publish the JUnit results. This is for the build step. Then the build step, you say that after this step has been built, what you want to do is then build a new job, which is test, that will execute all the tests. And if you see here the test, you will do Gradle test, blah, 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 all the scripts that you need to do. And finally, we say, and now run deploy job, which is going to deploy the project. And if you see here the project test or the job test, you have upstream project, which is build. It means that build is the one who has fired this project. And downstream projects, you see which build is going to be fired if this project success. And since you don't want to, that you want to reuse the artifact in all the stages, that the same WAR file that you have used in test, you want to be used to deploy to production. Probably you use the post-build action in the archive or copy artifact plugin, which you said, okay, I want to copy all the jar files and the Docker file. This is published somewhere in Jenkins, and then in the another job, in this case, for example, from test to deploy, you're going to say, okay, copy these files from the last successful build that has been fired me, and then I can do more things. So at the end, for each service that you want to deploy, you have something like this. 3 jobs, or more jobs, that 3 or more, which is one that for build the project, another one for deploy the project, another one for testing the project, and they are run, and every time that you need to run, to deploy, you call these 3 methods. And if you have 100 applications, you will have 300 jobs, which is, not very maintainable at all. So also I said that you are going to do code, not point and clicks, which is how you work with Jenkins. So what was released by Clubbies is the Jenkins Pipeline as code ecosystem, which basically it's a Groovy DSL for programming all the things that you have done doing point and click in Jenkins. Some of the features that have the pipeline plugin, basically that since you are using Groovy and it's a file, you can put this file into your source repository, so your application also contains the pipeline workflow inside your project. So anyone knows exactly how the project is going to be released. Let's click and type on more code, so you don't need to go there and say new build job, add build a step, add post build a step, and so on. It covers from the simple scenarios to complex scenarios, because since it's, the only barrier you have is that what lets you do Groovy. If it can be done in Groovy, then it can be done with Jenkins. One really interesting thing is that survives Jenkins restarts and connection loses. Pipeline, every time that they execute something, it persists to disk. So if, for example, the Jenkins goes down in the middle of a build, when you start again Jenkins, will continue in the last step where they was executing, because everything is persist. So he's smart enough to know, okay, this build has not been finished, and I know that you finished here. I recover the state, and I continue the execution. You can use reuse, that since it's code, you can reuse scripts. So you can define all the pipeline for all your projects in the same way and reuse it all over your applications. One thing that really works if you are using, for example, Git Flow or something similar to Git Flow, is that now you can Jenkins can automatically detect that the project has a new branch, so it can build it automatically without having to do any manual intervention of, hey, here there is a new branch or something like this. It's not necessary. Jenkins will take care of detecting this scenario. And there is a new UI for showing the progress of the continuous or the pipeline execution. So the only thing that you need to do is go create a new build job. This build job must be of type pipeline. You define your SCM where the project is. You define what is the name of the definition of your pipeline. By default, let's say that the factor name is Jenkins file, but you can use whatever you want. And in case that you have some trouble in writing the DSL, there is a snipper generator that you can use here. This is a combo box where you see all the options for the DSL, and then you push it here, and it generates the code that you can copy-paste to your Jenkins file. This is like a helper. The first thing to do with, or you can do with Jenkins file is defining a stage. This is something that is for documentation. Doesn't make anything more than saying, hey, I'm going to start the compilation stage. Then you define here node. This is because where you want to execute this part of code, you need to define a node. In this case, it's going to check the Jenkins, going to find an executor, and it will execute this code. Basically, it's going to be checkout SCM. This is taking the code where the Jenkins file is stored. Execute a shell script with Gradle, clean, compile Java. And finally, I'm doing a stash. Stash is the similar of copy artifacts. I'm going to take a common place in Jenkins, and I'm going to store the source files. And this is very important to do it, because now, if someone else commits something to the main repo, it doesn't. The sources are always the same through all the pipeline, because we're going to see in the next step, Jenkins is going to use always this source that is stashed. And then we have a stage commit test. The commit test can be run in parallel, and I said, use in parallel the unit test in one node, and stash the sources. So these sources are here. I'm not going to the SCM to check out again. Execute the test, save the JCO core reports, and publish the JUnit results. And in parallel, I'm going to use the integration test, which is in another node. This means that if you have a farm of Jenkins, you have several slaves, this is going to run in one slave, and this is another slave. So we're going to run pretty fast. And you're going to stash the source, you're going to run this in the happy path, and finally you're going to store the JUnit results as well. And this is going to be run in parallel. Another thing that you can do is, since this is Groovy, you can import Groovy files inside Jenkins Pipeline. Basically, it's a dev assemble. This is a method that calls run. Run is this method. So when I want to run assemble, I want to do Gradle, and I pass here the task, which is assemble. And the more important thing that cannot be seen is that you need to return this. You need to return this object. And then in your Jenkins file, you can do load Jenkins/Gradle.groovy, and I put here in a variable. And then I said, in a node that it's labeled with Linux, this means that for all the slaves that you have in Jenkins, the one that has a Linux installed, I want to stash the source code with emp. I mean that I want to set an environment variable, which is source build number, with the m.build number. So basically, I'm setting the build number inside as an environment variable, so my version project class can get it from here. I'm going to call Gradle.assemble. So instead of relying on shell, comma, and blah, 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 I can use more, the programmatic way of doing this. And I can reuse this file everywhere. Also, you can get input messages from people. This will stop the pipeline until you say if you want to proceed or not. You also can deploy to QA. Notice here I'm using concurrency number equal 1. It means that when I arrive at this point, any build of this project cannot only be run one at every time. So the other ones are going to be queued. And I can echo things. And if you want to, for example, push something, for example, tagging your version, you can use with credentials. You get the credentials from the credential administration. Here you define your credentials, and you say, with credentials, username, password, credentials is my ID. My ID is defined here. I get the username and the password in these variables, and then I can do git push and the Git username and Git password with everything there. And finally, if you want, you can even use HipChat or mail or Slack and say HipChat send, and you send this message saying everything is assembled. And probably a lot of people are using Docker or would like to use Docker. Pipeline also integrates pretty well with Pipeline. Here you can find some examples like Docker with registry, this registry, and these credentials. I'm going to Git, and this is doing a checkout from this Git repo, and I'm going to build that image. Basically, here when I say Docker build, going to take the Docker file and build the container, and with this name, and I put here the tag with an environment variable, and then I do a new app with this variable. That's the result of the build, push. And then what's it going to do is build the container and push it to this, to this registry defined here. You can even start a Docker container doing Docker image, this Docker image, and with run, it means that when the container is up and running, it's going to execute these scripts outside the container. So basically, you can do, for example, execute tests. And this means that the Jenkins slave are going to start a communication with this container. Or, if you want, you can do something better. This is executing code inside your Docker container. So you do Docker image, the HJDK. Inside, I pass all the Gradle artifacts, so they are not redownloaded every time. And I said, shell Gradle compile Java. And then, inside this image, that is a JDK 8, it's going to execute this task. And notice that you don't need to do a checkout, because by default, the workspace is mounted as volume inside the Docker. And this is the UI that I've mentioned that is something new, that you can see here all the stages. This is the stage name, and here all the builds, and you can see that all the steps, and here it's post. It means that here there was a manual step that I need to push. Of course, I've said that you can even use a multi-branch pipeline, which means that he detects automatically all the branch. Basically, you do a multi-branch pipeline job. You define here your Git repository, and it's mandatory that the file is called Jenkins file. So you only put this one thing, and what you get is that for each branch, it creates a new job. This is called master. This is the master branch, the future 23 branch, and when you do a git checkout -b and push that branch, Jenkins automatically will detect the branch and will add it here as a new job. So let's try to get some how we have seen today. Basically, we have seen only the one piece, that is how to program the pipeline. But remember that it's very important, the test. You need to write tests that you trust, because if not, you're not going to trust in your automation system. So this is another part. Probably at the branching strategies, everyone uses different branching strategies, something to be covered as well. So we have seen only one thing, one part. Then I would like to say that follow the rules, but adapt to your needs. I mean that some people say, no, the book says this, so we're going to do this. But maybe your company is not ready for this part, or maybe it's like, okay, we have like 1,000 commits every day. I cannot run all the acceptance tests, stress tests, and so on for the 1,000 commits I receive every day. So maybe you said, okay, we're going to execute only until integration phase, and then every night or every 3 days, I'm going to execute all the pipeline. That adapt to your continuous review to your needs as well. Well, I only say that CloudBees loves Jenkins. We are investing a lot of time, not only in Jenkins, but also in the plugins ecosystem. But of course, CloudBees is a company, and we have some products based on Jenkins, which are private. Finally, only the last is that it's not necessary to change to continuous delivery, because survival is not mandatory. And that's all. This is the best, the most important slide where you can download it. This is a slide, and the important thing is that here you can find the links of all the technologies that I've used. And yeah.
Any question? questions?
You have said now in the final that some of your products are not open source, are
Yeah.
private. All the things related to pipeline.
This is open source everything, yeah.
Okay.
Yeah, you can go to, you can download Jenkins 2 that comes, if you download Jenkins 2, all those things comes by default. If you're using Jenkins 1, it comes in a form of plugin. You can go to the update center and download it, yeah. It works as well, yeah. All right, thank you.